Let me start once Simon has joined. Oh, I can see Simon.
Of course, sorry.
Okay. Okay, then maybe I can start now, right? Thanks everyone for this dry run for GS1 talk. So this GS1 talk is intended for GS1 member organization interested in research topic about GS1 context, and but it's technically speaking, this is my field testing idea for my PhD proposal in a less technical approach. So, and this talk is only for 20 minutes. So I will happily answer your questions after the talk, but I will try to fit in a 20 minutes framework. Okay. My talk is about explainable industrial automation, and my name is Iori, and I have been with AutoID Lab Japan for 5 years, and I have done bachelor and master with AutoID Labs in Keio University. And after that, I came to Switzerland and joined Interactions and Communication-Based System Group at University of St. Gallen. And this Institute of Computer Science has been only recently founded, and I'm one of the first PhD students. And last year, our group is once again part of the AutoID Labs. So I am back in the AutoID Lab. And this is our team. Okay, today's agenda is I will briefly talk about industrial automation systems and introduce some challenges for semantic interpretability. And I want to discuss Web of Things and how we can enable explainable industrial automation systems. First of all, industrial automation systems, brief overview. This image shows a life cycle of retail products sold at the proof of concept convenience store with an automatic checkout system with RFID. This is the work project with the Japan lab has been involved. But we all know that if we can track products for the entire trajectory in the supply chain, everyone will be happy and utilize the information to enhance the ecosystem. And we can use the information for sales and optimize the manufacture plant and so forth. But today's talk is mostly about this part, supplier, B2B. And before we talk about industrial automation system, let's take a step back and think about industrial IoT. On one hand, for the comparison, the smart home can be built with affordable price range equipment, and you can append as you like you can add valves and home control and home theater and audio and so on. But for the factory, smart factory is often start talking about 1 million US dollar and beyond, and it's quite challenging for thinking about acquisition, because most of the case it is a replacement of old appliances, which are also heavily integrated to the shop floor and involves migration cost. So as for the automation, it is quite easy to think that automation can solve everything and we can remove the redundant work that the human is suffering. But in reality, it is not that easy. So I want to elaborate what is the challenge in the shop floor. In the industrial automation system, this automation pyramid is often used to describe different layers of the system. And OPC-UA is the dominant standard to provide uniform interface in the different components and enable the communication between the components and other part of the system. But still, we have some problems to solve inside this automation pyramid. And I will show you exactly. And semantic interpretability inside automation pyramid. There are different service components inside the automation systems. And this system is designed according to the service orientation architecture, which is making the monolithic systems more modular and interoperable. But in order to flexibly adapt the new components into the system. But inherently, it is complex, and this complexity obfuscates this decision flow and the logic in the systems. So the future industrial automation system should be self-explainable for engineers, operators, and auditors and different stakeholders to comprehend the behavior of the system. For example, in the ERP management layer, the one order initiates some actions in the automation systems, and it associates the required resource allocate management and operational scheduling, and who needs to be there to execute the tasks, and finally build the batch production, for example. In this case, what we want to know, the production line X is operational under the supervision of Y services in the manufacturing execution system, which is originated from the order Z at the ERP system. This kind of provenance of event is quite important for humans to understand what is actually going on and why it is actually happening. Next, some challenges for semantic interoperability. One of the reasons that is quite difficult to achieve the semantic interoperability is because in the factory, we have different types of machines. And machines usually talks different protocols, uses different data models and use formats and so on. And on this example, the left-hand side is the turning machine control interface. And this has been developed since 40 years ago. And therefore, the data format is based on this tape format. And this tape format is converted into the strings of commands. And nowadays, we are still using this. And in the other example, in the conveyor belt on the factory, they are still dependent on the basic analog PLC controller, and we have to know which wire goes where. And the same for robotic arm. Although we have a more concise framework to control and plan the motion of robotic framework, they are often incompatible with existing system. So we have to absorb these different in communication protocols and other interface heterogeneity. Other aspect is identification of object. In this example shows how we use the multiple standard identity and how we capture them during the supply chain, in the supply chain. And when we manufacture industrial product, we start from the material, and material has a proprietary ID, which is in this example has a metal lot, has a melting point number, and this identifies which oven it is being produced. And after dispatching this metal lot to a manufacturer, then this melting point number will be banished after washing the part. And this makes us quite hard to track the object in the entire life cycle. But after we create metal parts, we put this kind of another proprietary ID with a data matrix, and then shipped to another manufacturer to be assembled with the parts. And the in terms of semantic operability, what we want to solve is how do we create transformation events in EPCIS, and how can we capture these volatiles IT and track physical object to bring this up into the application layer. Another example for the semantic interoperability is that in the left-hand side, we see the container terminal, and we have enormous traffic of RFID events to identify which container contains what kind of products and so on. But this has this has lots of RFID leader components in the floor, so that we want to optimize the operation. For instance, what kind of interrogation power it is being deployed, and what is the report interval, and what's the size, and does RSSI filtering is needed, or does it contain user memory, and so forth. And this kind of configuration can only be done through the this semantically interoperable systems. Sorry, I have to re-practice this part. So to summarize, we have these feature requirements for explainable systems. One is a traceability, which includes the provenance of events and how to track the physical object for the system. And the second part is interoperability, if it has what kind of interface it is used and what kind of information model. And when we talk about transparency, this is mostly about how to access the underlying implementation details for better orchestration and of distributed components like RFID readers in the previous example. And the fourth part, I haven't talked about it in detail, but this is to adhere the safety and the security requirements of the industrial automation system, because the robotic arm and the belt conveyor, it is quite dangerous for human operators. So we have to be conform to the policy and the regulations. And these requirements consolidating to the explainable systems. The third part is about the Web of Things. Okay, so we are currently trying to use the Web of Things technologies to fill the gap between the cyber and the physical space. On one feature is a to solve the to integrate the heterogeneity of the system by using the semantic description of the things of the industrial automation system, using the principle developed for the web. And secondly, this service orientation architecture often has implementation detail to allow interoperability, but this complexity still remains, and this complexity can be alleviated by placing the semantic overlay of Web of Things, as well as enhancing the semantic interoperability. But this presentation is too short to go in deep. So if you are interested, then please let's talk after the conference. And finally, I want to briefly talk about the relevant effort for the explainable IAS in the GS1 context. The first one will be the digital link. Digital link is the effort to represent GS1 identifier in URI. And in this example, we have this individual object assigned with SG10, and it has QR code with this digital link embedded. And what is cool about digital link is that we can use this digital link to create the semantic description of this thing as a key. And we can, with this semantics description, we can associate this physical object with other digital representation, for example, the thing description of Web of Things or like EPCIS object event, quite easily. So this is quite handful for integrating this into a Web of Things ecosystem. The other one is LLRP. LLRP is the GS1 protocol for RFID reader management. And this year, the LANE, the RFID Reader Alliance, and GS1 has called for the LLRP update, and after 10 years, because the last version is issued at 2010. So, but what they are going to solve is the LLRP has been supporting vendor extension, but this vendor extension has been implemented in different ways depending on who actually provides the RFID reader writer hardware, so that end users cannot mix different vendor components in their systems. So the newer version of LLRP is going to absorb this heterogeneity inside RFID readers, and also this RAIN communication interface is built on top of LLRP, but use JSON object for message payload, and it is suited for MQTT or WebSocket or PCUA, and this is again can be easily be integrated into Web of Things ecosystem. In summary, industrial automation systems are becoming more and more complex and require explanations. And gaps among research, engineering, and operational domain are creating bottlenecks to provide various feature requirements for the explainability, semantic explainability in particular. And Web of Things can be a good enabler for the semantic interoperability in the industrial automation systems. And thanks for listening. And this is the end of the presentation. I'm sorry, I have to admit I have to practice it more, but I would love to hear your feedback.
Oh, I'm muted. Yuri, cool. I have about 3 pages of feedback. I was typing the entire time.
Good, great.
But I think that the overall story, I think, is good. I have several ideas for rehashing it. Mm-hmm. My only general I will tell you one general comment, and then I will give you an example of this comment, and then I will stop speaking. My general comment is that overall you need to pull it one layer up, one layer out of the technical implementation and into the business implications. Let me give you one example where I think this ideally fits, and that is slide 16.
Okay. Page 16?
Yes. Okay. So on slide 16, you're telling me we can then associate. Yeah, here we go. The left part of this. So can you click back 3 times? Yeah, now this. The story that you were telling here is very, very good, I think. It directly links to GS1, it directly links Digital Link, and it directly implies a business value, but you didn't talk about that business value. What you were saying here, we can then automatically associate this with an EPCIS event. Right? Make it clear what the implications of this are. So first, I would again take the Louisiana DNR example that you brought up before. You can nicely fit it in here. And second, I wrote down, it doesn't help to say that we can associate this with an EPCIS event because people won't have a good idea of what EPCIS is. Rather, tell them You will, for instance, be able to trace where your materials are coming from, because this is directly linked to the EPC information system.
I see. Right, because when I say EPCIS, then that only confuse people, because
Yeah, but
they don't know
I
what
mean,
that is.
for these people, EPCIS is only an infrastructure, right? They are not technically interested in it, but they are interested in the value it brings to them. And now here I have a very concrete and very timely version of timely story about the value, and I hope that Damian will agree with this. Now, in 2 weeks, I think Switzerland will vote on something that's called the Konzernverantwortungsinitiative. That's a political initiative that would regulate companies into being able to trace exactly where their source materials come from, whether there's ethical work conditions there. Okay. Now, this is directly relevant to what you were saying here. If I get a globally standardized identifier on my raw material, then I will then, since I can link this using digital link to EPCIS, I will be able to directly comply with such initiatives. See what I mean? Damian, you might be closer to this. You might even be an opponent of the Konzernverantwortungsinitiative. I guess you might be. But what do you think? Is that a thing? Tracing of raw materials?
Yeah, because there. Can you hear me? Does that work?
Yes.
Yeah, because there is no standard. So today we do this by using the ISO certificates. So we have to track our suppliers, but in a very unstandardized and not really a serious way.
And this is precisely what I mean. And this is great what you brought up in slide 11. In slide 11, I thought this was extreme. This was very, very explanatory. I understood what was going on there, and I saw the problem that down on the material, on the parts part, we're using proprietary IDs, and so we cannot do tracking, so we cannot do tracing, so we cannot do accountability, so we cannot do explainability, and so on. My suggestion, last sentence, is to use slide 11 right after slide 5 as an example to introduce the entire problem. Then use slide 12. Then use slide 16. You're getting all of this in writing. Then use slide 16.
Okay.
And then go back to slide 13. I think that this would give a great storyline. Now I will stop speaking.
Maybe I can add some things to slide 11. So my biggest problem, of course, that we have a number on this pipe and we don't have it after the surface is gone. What I also see here is that with this number on the raw material, we get certificates from the raw material supplier.
Okay.
First document, sometimes it's even a scanned document, not well readable. Then we have our own system of working with these numbers. That's our ERP system.
Okay, so to associate this certificate came with this melting point number.
Exactly.
Okay.
And while doing it in our own system, we also send it to our customer, and they give us a batch ID number that links the certificate with the product, their product article number. And then there's a third database with the serial number that's also linked to the batch ID of our customer. And this serial number then is printed in or engraved in this data matrix code. So we have like 3 different systems with different, or 4 even, from our one from the raw material supplier, our own ERP, and then our customer's batch ID system and their serial number system.
So if we can aggregate those in non-proprietary way, then that would be useful.
Yeah, that would be much easier, because today we really send them our material certificate we get a batch ID, then we send again to the same person the batch ID, and we get a serial number. And then when they receive our deliveries, again, they fill in the serial numbers we have chosen from the ones they sent us, because they send us a lot of numbers and we can choose which to pick. And I guess it would be easier if this would be standardized, because we all build our own databases, and that's just with one customer. So if we look at another customer, the process is totally different.
And if I remember correctly, you had different different material IDs for same batch ID and vice versa. So for some article that you produce, you may have different melting point number for raw materials.
Yes, of course. As soon as the mixture of steel is melted, there comes another mixture, and this other mixture gets another melting number.
So how is it now managing this different segment of group of the final article, final product that you're shipping? So one article is associated with one melting point material group, and the other is associated with another group, and they are but in the same batch ID group.
No, batch ID only contains the same melting number. As soon as melting number changes, we send the new material certificate
okay, I see.
to our customer, and they send us a new batch ID number, and we stamp it on the part and include it in the data matrix code.
I see. So the batch ID and material melting point number is one-to-one mapping.
Yes, but in a different format. Also, the melting number is a 6-digit number, and the batch ID is 7 numbers. And you can't see it how they are linked together. It's just in our customers database that links them together.
I see. Thank you. I forgot about the certificate, importance of having the certificate of the raw material, and this is quite good point and has a business value, I think.
That's the thing we have, or that's the thing that is interesting, and the number is just the representation to have it on a part or on a sticker or whatever. And maybe that second comment, in some slides before, you said that we only focus on the supplier. So I do not understand that, since we give this information to our customer as well. And in our storage, we have to see which parts with which melting number are stored in our stocks.
This image is not quite suitable for this presentation because this is about B2C.
Okay.
I couldn't find prettier picture than this.
However, audience-wise, you're expecting lots of retail people in the audience. So I wrote great for this picture because it establishes the link for these people. Oh, here is my store. That's what I know. And now this guy is talking about what comes before. Now I understand.
So I use this as an introductory image gateway slide.
Yes, gateway slide.
And maybe at the end, if our customer delivers its machine to a customer, to a chemical plant or whatever, so why we are doing all this is that if a pipeline explodes that contains a machine of our customer, then they have to describe the whole supply chain to see
wonderful.
where the problem comes from.
This,
That's
this
where
also,
it becomes B2C, but for us, of course, we don't care about the end customer.
This also connects pretty well with accountability.
Yes, exactly.
For this slide, I was putting, I think that accountability is the thing that your audience will understand best on this slide.
Okay.
For the others, I said,
this is bit
I said make it
technical.
more blunt. For instance, what's the business value of interoperability? It is that you don't get locked into a single supplier. What's the business value of transparency? It is that I can better understand and repair my system without being dependent on a single maintenance person, maintenance supplier, and so on. But this is more on that level.
Okay.
It's good what you're putting there. I mean, the technical content is good. I think it makes sense. The digital link with RAIN specifically, and then enabling traceability. And I think this makes a lot of sense with the semantics on top of it to pull it together over the entire stack. This makes a lot of sense, but not to these people maybe.
Right, you're very right. I have to bring this up one layer above.
But I don't think that this I don't think that this changes a lot in your slides. I think it changes a lot in what you're saying.
Business value, right?
And see, for accountability, you even have it, right? So for interoperability, what you say is uniform standard interface, and you say shared information model. So technical advantages. In the accountability, you say adherence for safety and security requirements. That's on a different level.
Yeah, right. Does anyone have more feedback?
Yuri, just a few points from my side.
Yes.
It was great. I mean, I had like a very good end-to-end overview of what you were telling. What was slightly missing is the connection to the first part where you had the problem of interoperability in an industrial environment. And then when it transited over to identification and the interoperability of identification, the business value behind interoperability, where you cite like one traceability, accountability, that somehow seemed to be kind of facing outwards towards like customers, suppliers, consumers, and so on. But what about interoperability between elements in a factory? Say, you get one of those raw material which is like identified, and you can link it to its semantic description. Is it a potential use case that this enables machines to understand what they are processing, and somehow you don't require a human in the loop to fill this gap, So like a robot picks up that rod and knows the attributes of this rod, and before it decides to put it into a lathe or some other machinery, it has already resolved this capabilities that the machine is capable of machining this raw material because it understands now the semantics of it. Is that already a use case, or sounds like too futuristic?
And I think that is precisely what Damian has long wanted, but I think the challenge there is because the machine is so primitive, and like in this picture, like Damian washed this metal rod to the cleaner state, and this washing machine is completely primitive and it requires human assistance. And I'm not aware if there is a fully automated metal washer, but in the ideal world, yes, that should be how it should be doing, like understanding what kind of raw material it is processing, and process it as in the description of the order sheet or something like that. But I think that's kind of 1 or 2, 3 steps further. But do you think I should mention, or at least somehow I can connect it with this talk? Maybe right, because I talk about semantic interoperability, right?
You can bring it up on the side. I would agree with you that the audience is not the best one for this, but on the side you can bring it up. For this slide, even I was writing down, in this slide I felt betrayed, because you showed me material, you showed me part, then it was over.
Mm-hmm.
And maybe you can mix in Ganesh's points when you talk about the higher levels of the system here. You should talk about the entire stack. I mean, up here, I mean, the narrative is down here. It's very bad. There's proprietary ideas, so we cannot do anything. I'll show you later on what we can do about this. And then as you go up, here we do have ideas, but they're not attached to semantics. If they were, maybe the machine could understand what it's processing, just like what Ganesh was saying. So because generally I thought this slide was great to structure the talk.
So to align more with the higher purposes.
Yeah. I mean MES and maybe even ERP, yes.
I think I have to restructure this with the business value of attaching certificate, and also to communicate with the customer. Great, thanks, Ganesh.
Thanks. Just a few minor ones.
Yes.
When you started, I mean, just going through the sequence, on the team slide, I thought either you could skip it or maybe say a sentence or something. It seemed to just flash by, like,
okay.
So I thought like maybe you could say like the composition of the team is in a certain way that helps you, or that was one. Then I kind of got the feeling you were hesitating in some places where you really didn't have to. You were flowing very well or nice, and then maybe suddenly you felt uncomfortable. But I really felt you were going great, and you had no reason to feel uncomfortable. That's just kind of a philosophical point.
Yeah, thanks. But it's only because of the lack of practice. I just made the final changes in last minute, so I just forgot how to structure.
Or maybe also you don't see the faces and reactions that might also be a little bit unnatural,
Okay.
That's very disturbing. Yeah. I agree.
Yeah. So otherwise, the other points are already covered by Damien and Simon.
Okay.
Thanks.
I will practice for my final recording will be on Sunday, and I will send it to GS1. So by then, I think I have plenty of time. Not plenty, but enough time.
Yeah, so really great presentation, Yuri. So really nice, and also a very nice slide deck. I mean, yeah, really. I can imagine it was a hard task to synthesize everything so nicely.
I tried to go less technical, but I ended up like this, so I'm still not good at abstracting things.
Well, for me, the level of technical detail is not bad, in the sense that you also want to show that you have the expertise, right? So I think it helps with that as well.
Exactly.
To show technical details.
That's what I was meaning. What I meant before. Don't necessarily change the slides.
Yeah.
Right, but just change the rhetoric. Just contextualize the technical stuff more.
Okay.
Yeah. So in my words, don't dump down the presentation because it's great. Just make it more appealing for non-technical people in the sense of showing what is really the benefit of all the technical points that you are making.
And I think you were at 18 minutes or so. So you can take more time with conceptualizing in that way.
Okay.
Yeah.
Sorry, I think Andrea interrupted.
So really nice slide deck. For me, there were also just 2 cut points in the presentation. So the first one, the one with the team slide, I also wanted to mention that you can even skip it or otherwise use it somehow in the discourse. And for me, there was also a bit of a disconnect with part 3 with the Web of Things. So it seemed like it wasn't very clear why you brought that slide into the picture, because it seemed like it was a bit out of place with the rest of the presentation. So if you remove that slide, I don't think you lose much from the presentation.
I try to connect these things in, but as I put it here, as for the excuse, I think it's not doing a good job to give a context, as you said.
It's really the bridge. I was writing down here, cast this slide more in a how to actually implement semantic interoperability way or something such. How to do this now? How to? But I agree with Andre. It's the bridge is missing with this one.
Yeah, and in my mind, I see semantic interoperability and the Web of Things as 2 different things. So you don't need necessarily the Web of Things to achieve semantic interoperability. So semantic interoperability is a big part of the Web of Things, in particular the W3C Web of Things, but there are 2 distinct things in my mind.
Yeah, but I want to, so how to implement that semantic interoperability, I want to use Web of, I mean, I see the Web of Things is a key. Key technology or bridge.
I
will try to think about the bridge, smoother bridge, either with a slide or more, maybe a little modification in this one.
Okay, and I only
sorry, Andre, can I just the Web of Things link potentially could have worked nicely, because these identifiers which actually link you to the semantics or metadata of the thing itself, even if it's a raw material, forms like a very crucial link between the thing description and what it is. So I'm just maybe taking a use case and fantasizing about it. So if there are materials which we traditionally don't consider them to be thing description in Web of Things world, okay, say a raw material which has this metadata and it links me to the semantics of it, plus this raw material has certain behavior. For example, when exposed to air, it changes its characteristics. Okay. So if this was modeled as a Web of Things thing description, it could have had a kind of a story behind. That was my feeling.
I think this slide, I can integrate the Damian's story for the material and raw material, and different batch number and article number needs to be considered in one single place. And I think this digital link example will be a perfect solution for that.
Okay, and I only had one tiny comment for slide 8, so page 8. This is really just a small comment. So I don't think you can see it because of the bubble there. Yeah, so here I think that I would use service-oriented architecture just to make service-oriented as an adjective. Yeah. This is just a minor thing.
There's a typo. Sorry. Thanks.
Okay. So that's it for me.
Thank you, Andre.
Yeah, thank you. Really nice presentation.
Damian, does photos okay like this, or do you okay, good? And do you still need the list of the participants?
Oh no, that's
okay.
No problem.
Okay.
Maybe on this photo, is it possible to get something which zooms into that lowermost identifier a little bit more? I mean, it kind of draws the curiosity, but I was just wondering if it's have a better picture there.
And it would emphasize how non-standard it is.
Well, I was also concerned about this because this is kind of private information of Damian's customer. So if I you know,
that's no problem. You can zoom in. I can even send you pictures of that with a more detailed number. That's standard. I mean, for raw material suppliers, every raw material has such a number on it, so that's not a problem.
Mm-hmm.
And the data matrix, same thing. That's just a number, a 10 or 15-digit number.
Mm-hmm.
I have one comment.
Yes.
Of course, I like the presentation because it's always really good, better than me every time. So it's really nice. But after slide 8, you talk about transparency, which is one of the biggest part of explanation. So I'll talk mainly about that. I somehow missed it in section 2. And then you're talking in section 3, we are related somewhere there, but I somehow missed this part. Yes, it was not emphasized as much, I guess, to relate it with explanation. Because you're talking about explanation and merging it towards in this. So I thought that it would be good to emphasize on that and also put some, as Simon said, about business, value, how it adds into the business value. So it would lead towards the explanation why it is important and why it can be the future of GS or why GS1 can go to. Explanation. So that's what I missed there. Otherwise, yeah, I like everything, whatever you have done. Thank you.
Yeah, but you're right, because I didn't explicitly said that explainability or explanation is a quite big umbrella term, and I selectively focused on these 4 domains to in the hope of aligning the story in these 4 domains. But these use cases are not very much aligned. I mean, this one, I think as I was talking, can fit, but this one may be quite hard for audience to understand what I was trying to say.
Yeah, because I thought that you tried to tackle this accountability, traceability, because those are all from the provenance area mainly. And everything is mentioned here and emphasized in the correct way, I would say. But the transparency part was somehow suppressed. Or not emphasized as much. What I guess is the important stuff in this this presentation.
I think transparency that I want to show is the transparency in here, because we in the control interface of RFID reader, we cannot do the better configuration at runtime.
Yeah, so maybe emphasizing a little bit on this and also how it is gonna add value to customer and the business. That could emphasize the transparency part, and story would be better in explanation way. Yeah, thank you.
Thanks. And I see the chat. Okay. Simon has typed the melting point number.
do you interpret that? How many degrees Celsius would that be?
Is this a degree of Celsius or like a configuration of the oven? Was it, Damien?
No, nothing of that. It's just a number, and the certificate has the same number, and everything like oven temperature and the ingredients of the steel are mentioned in that certificate. But this is actually just the certificate number.
So it's just allocated number for the material certificate, which contains melting point degree.
Exactly. Not only degree, it's mainly about the ingredients, because you have some milligrams of nickel or whatever more than in another recipe of the steel, and that's what it is included in the certificate.
Are these certificates some kind of like machine readable entities?
No, not at all. If, for example, if we get certificates from material from China, that's really a scanned, very bad readable piece of or PDF, and you can't really use that. And they all have different layouts. So if we order from a supplier in Germany and a supplier in Italy, they look totally different. And also the format of this number is not always the same. Sometimes it's 6 digits, sometimes it contains letters and so on.
And this particular metal rod was from Sweden, right?
Yes, exactly. From Sandvik, Sweden.
Sandvik, yeah.
Sandvik, S-A-N-D-V-I-C, I think.
Right. Thank you, everyone. If we do not have any more comments, then I would like to thank you all. And once my recording is ready, then let me share it with you all. All right. Thank you very much, everyone.
Thanks, Yuri. Thanks, guys.
Thanks, Yuri. Bye.
Nice afternoon.